Let's solve another LPP problem using graphical method.
This is a problem which talks about a tricky scenario where we have less than equal to constraints, greater than equal to constraints, and equal to as well. So, with a combination of all these constraints, how do we plot a graph?
So we have been given the objective function. We have this many constraints here. We have 1, 2, 3, 4 constraints are there. So what is the next step? We will arrive at the points, because to plot a graph we need points, right? So first we'll take the constraint number 1, x plus y less than or equal to 8. So what we will do? Substitute x as 0 and obtain y. So y will be 8. So the first point is 0 comma 8. Similarly, we'll take y is equal to 0. We'll get x plus 0 equal to 8, which means x is 8. So second point is 8 comma 0. Now let's take the second constraint, x less than or equal to 5. So here in this case, there is no need of getting any point. We'll have to just draw a line tangentially at this particular point. At x is equal to 5, we will have to draw a tangent. Similarly, for y less than or equal to 5, we'll draw a tangent at y is equal to 5. Let's take the fourth constraint, which is x plus y greater than or equal to 4. So which is nothing but x plus y equal to 4. So we'll take x is equal to 0. We get 0 plus y equal to 4. Y is equal to 4. So what is our third point? C. It is 0 comma 4. Now we'll take y is equal to 0. We'll get x plus 0 is equal to 4. That is x is equal to 4. So our fourth point is 4 comma 0. Now we have 1, 2, 3, 4 points, and then we'll have two tangents for this one and this one. So let's plot this graph roughly. This is the origin 0 comma 0. What are the points we have? 8, 4. Okay, so we'll take units of 1. So what's our first point? 0 comma 8. X is 0 and y is 8. First point is A. Second point is 8 comma 0. 8 on the x-axis. So this is B. Now we have 2 points. Let's join these points. So we have first constraint, which is x plus y less than or equal to 8. Now let's plot point C, 0 comma 4. So this is point C, and 4 comma 0, which is point D. Let's join these 2 points. So we have got the second constraint here, C and D, which is x plus y greater than or equal to 4. I'll just put it in black so it's easy to identify the lines. Now we have another constraint, x less than or equal to 5. So when we have something like this, we'll have to draw a tangent at a particular point. It is 5 there. X is equal to 5. So we'll take this point on x-axis and draw a tangent like this. Similarly, we have y less than or equal to 5. So on y-axis at point number 5, we're going to draw a tangent. Tangent is nothing but a perpendicular line. So we've got there is an intersecting point here. Let's call it as E. Now let's do the shading. Let's take the first constraint, x plus y less than or equal to 8. So when it is less than, the shading has to be inwards, towards the origin. So we'll have to shade it like this. Now we'll take the second constraint, x plus y greater than 4. So it's greater, that means it's going to go outward, above the line. So this is our constraint line. So it's going to go above, like this. Now we'll have to take these two tangential lines also. This one is x less than. So if it is less than, we'll have to shade it on the left side, again towards the origin. So it's towards the origin. So we'll shade it like this. Now similarly, we'll take y tangent, that is y less than or equal to 5. This is less than, again towards the origin. So it will be like this. So we have shaded all the 4 constraints. Now we'll have to find the overlapping region. Now, which is the overlapping region? Region which has the maximum number of shaded area, right? So where is the maximum shaded area? This is the area that we have. There is shading here also, right? So we have several points here. We'll have to take all the corner points or all the vertices, or rather all the intersecting points. Now this is one intersecting point. See this one. This is another intersecting point. This is another one, and this one. So we get 1, 2, 3, 4, 5, 6. 6 points. This point is point number C, point D. Let's name them. Let's figure out what this point is. This is at 5, 0, 5. Let's call it, say, F. Let's call it as F. Then we have another point here. This will also be, x-axis will be 3, 5. So let's call it as E, 3, 5. X-axis is 3 and y is 5. Then there is another corner point here. This will be 5 on the y-axis, and x would, 5 on the x-axis. Y is 3. Now this is another intersecting point. So this is 5, 0. This one. So what are our corner points? First one is C. C is 0, 4. 0, 4. Then D. D is 4, 0. C, D. Then we have E. E is 3, 5. Then F is 0, 5. Let's call this as G. G is 5, 3. And we have this another one. We'll call it as H. H is 5, 0. So we have 6 corner points. And this is our feasible region. Now using these corner points, we are going to obtain feasible solutions. We are going to substitute all of these points in the objective functions. So objective function is x minus 7y plus 190. So let's take the first point, C, 0, 4. Let's take 0, 4. So what we are going to get? X is 0, y is 4. So 0 minus 7 into 4 plus 190, which is minus 28 plus 190. So we're going to get 162. Now let's substitute next point, which is 4, 0. So x is 4, y is 0. 4 minus 7 into 0 plus 190. We are going to get 4 minus 190, which is 1. 4 plus 190, which is 194. Now let's take the third point, which is 3, 5. So x is 3, y is 5. So 3 minus 7 into 5 plus 190, we're going to get 3 minus 35 plus 190, 158. Let's take the fourth point, which is 0, 5. So x is 0 minus 7 into 5 plus 190, we'll get minus 35 plus 190, which is 155. Fifth point is 5, 3, which is G. So x is 5, y is 3 plus 190. 5 minus 21 plus 190 is 174. And the last point, which is H, 5, 0, we're going to get 5 minus 7 into 0 plus 190 is equal to 5 minus 0 plus 190, which is 195. So all of these are feasible solutions. 6 feasible solutions we have. Now out of this, we'll have to get the optimal solution. Optimal solution Z, we have to minimize this. So we have to find the least of these values. Which is the least of these values? 155. Optimal solution Z minimum is 155. and it occurs at which points? 0 and 5. That is, when x is 0 and y is 5, we get optimal solution or the minimum value.